Hello, my name is Emilio and I'm a student from the Universidad de las Américas Puebla, and I'm going to talk about our density experiment, floating objects in water. So, the density is a physical property that describes the amount of mass contained in each volume of a substance. It is calculated by dividing the mass of an object by its volume. Density is commonly expressed in units such as grams per cubic centimeters or kilograms per cubic meters. In the context of fluids, such as liquids, density is a fundamental property that influences the behavior of objects that are immersed in them. According to the Archimedes principle of buoyancy, an object immersed in a liquid experiences an upward force called the buoyant force that is equal to the weight of the liquid displaced by the object. The buoyant force allows objects to float in liquids if their density is less than the density of the surrounding liquid. If the density of the object is greater than the density of the liquid, the object will sink. In this experiment, we aim to investigate and quantify the influence of the density of objects on their ability to float or sink in different liquids. To do this, solid objects made of different materials have been selected, such as wood, aluminum, and rock, each with a known density or that can be precisely measured. The procedure for measuring the density of objects involves obtaining the mass and volume of each object. Mass is measured with a precision balance, and volume is determined by measuring the dimensions of the object with a ruler or caliper. Density is calculated by dividing mass by volume. Flotation tests will then be carried out on transparent containers containing various liquids with different densities, such as water, glycerin, and oil. When each object is introduced into the liquids, it will be observed whether the object floats in the liquid, sinks, or remains in suspension. Observing these behaviors will allow us to establish whether the density of the object is greater or less than the density of the liquid and how it affects its flotation. As we can see in the chart, we got the materials and the initial height when we added a fluid to a recipient. Then we dropped the material or the object into the recipient with the fluid, and we got also the final height. Then we got also the initial weight of the material and of the fluid in the recipients, and then we got the total weight when we drop the material or object. With this data, we obtained the volume of each of the objects, and also we got the density of the liquids that we use, that are the oil, the glycerin, and the water. With all the obtained data, now we can make the calculations for the mass of displaced water. This is obtained by multiplying the object volume plus the water density. Then with the mass of displaced water, we can calculate the buoyant force or buoyancy force. This is obtained by multiplying the mass of displaced water plus the gravity. We all know that the data of the gravity is 9.81. Then we can calculate the weight of the object, and we obtain that multiplying the object mass plus the gravity. In all the cases, the buoyant force is less than the object weight. As a result, the object will sink into the fluid. This calculation shows that since the weight of the objects are greater than the buoyant force generated by the liquid, the object will sink. As we perform the experiment with different fluids, we can say that the sink time is different also by the object. We can say that the aluminum cylinder and the rock takes less time in sink in all the fluids, but there's also the density of the fluids that it takes more time in the dense fluid than in a less dense fluid.